So we saw our arrays and slices, right? Now let's look at our all other major, of course, data structure, of course, is a map. What we know, of course, is dictionary in Python. What we know, of course, by other names, hash map, right? Associative array, right? And why do we need it? Of course, is because why do we need a map? What do we get with using map? What's it? What does it give us? Like a dictionary, like okay, I'm in Python dictionary. Why do we use dictionaries? Why do we use? Why do we need this kind of structure? Key value, yes. And so what is? Why is it good?
You could do something different.
Yes. So addition, reminder, big O cheat sheet, right? Big O cheat sheet. Yeah. Very good. Again, you see, you sort of vaguely remember. You're not completely lost, right? No. So hash table, right? That's basically what it is. It's a hash table. So we have O1, a good hash table on amortized in average, right? O1, O1, O1. Well, theta 1, theta 1, theta 1, right? So, of course, a bad worst case hash table will have a linear performance, right? But we don't get that. Again, we don't worry about it, right? A good map implementation, which resides everything. So, maps in Go programming language give us key value pairs, right? Are unordered, reference types, dynamic. We can resize them. Yeah, access, right? Access is constant time, O1, right? Well, it says O1. Deletion, constant time, and insert is also right. So search by key, of course, right? By key, of course, constant time, obviously, right? And of course, not thread safe. There is a sync package that can be used to make that step. Yeah. Well, we can compare. We can figure out some. They're not directly comparable. But okay, let's not do that. Okay, so let's take an example. Again, package main. We'll do package main, right? Just click on import formatter, right? Of course, we want something like that. On function main, since we'll do right something like this. And well, let's say let's create a map of names from Alice, Bob, Carol, Charlie and Dave, or Carol. Let's do Carol and Dave, right? On their ages, right? Let's do that. Come on, I'm lazy. I don't want to type code, but let's do that anyway. So ages, right? Ages map, right? So this example, right? We actually could have done this immediately, right? We could have done also an empty map, right? Ages, right? And let's print them. Right now, let's now print the map. And we can do this, by the way, too, right? It's nice. So map string to integers. So keys are strings here, and values are integers. Remember, static typing, right? In Go, right? Unlike Python, right? But of course, like most is statically typed, right? So let's take a look, right? And of course, and as you can imagine, oh well, we don't want arrays. I want Go build maps. Go. Oh, they really call it maps, not Go. Come on, let me rename it. What kind of allow? Rename it. Rename Go. All right, hookup. All right, let's do that. Go build maps, and we will run maps as maps. And we don't have maps yet, but we should have it. Let's take a look. Yeah, it works. Map Alice, Bob, Carol, Dave. Right. We could have an empty map, right? We could have an empty map. We can get value by key. Alice, right? She should be 25, right? How about we can delete Dave? We can delete key. Right, let's get, okay, poor Bob. Bob is gone there, right? And we can, of course, we can also add a new key. Let's add Eve. Let's add Eve. Key value pair to a map. let's say, let's add Eve. Okay, how did AI know what I was gonna add? Yeah, smart, very smart. So we're doing maps right now, again, because of course we have our O1 performance, right? But the only thing is they're not ordered. I mean, I could do by the way, I could do also, I could do looping, right? It does not necessarily require show that what you call the order is not guaranteed, right? Remember in Python, in many hash maps, you have the order of insertions guaranteed. In technically, Go does not guarantee it, right? But let's take a look at loop. Let's loop through. Let's look at this idiomatic let's. Yeah, yeah, we can check. Yeah, so this is very interesting. How does it do? So, right. So let's take a look. Yeah. So, yeah. So this is interesting. So this is your first encounter with Go error handling. So oftentimes Go will give you two values, the actual value and of course the error value, right? The OK in this case, we call it OK, right? And so Alice, right? So this is very Go, I was going to say Pythonic, it's Go, Gopherish, I don't know what to call it, whatever. Go style, Go language or something, right? I'm sure they have some sort of nickname, right? Again, I enjoy language. I'm not a full-time gopher, right, or whatever they call themselves, right? Yes. That's what they. I think that's they use, right? Yes. Well, I guess so, right? All right. So they thought this kind of. So, Alice exists, right? If not, if okay, right? So it's a Boolean, right? It's a Boolean, right? It is a Boolean. Yeah, right. But it's not. So this is so above is a very typical on how possible errors is done in Go. So this is also similarly. So this is you will see pretty much all of the Go language code will be full of these error checking code, lots of ifs like that, right? That's what you do when you write your code. You have to check if something worked, right? That's how you do error handling in Go, basically. All right, so we know how to do maps. We check in existence. We can do delete. We can iterate. Oh yeah, let's do iteration. Let's do iteration, right? Right. So now let's iterate over the map, right? So for key value in range ages, right? So we print. So we get or key value, right? And we will be able to do whatever we want to do with these values, right? So let's see if the order is Eve should be last, Alice should be first. I don't know. We'll take a look. Yeah, actually no. You see, Dave, Alice, Eve, Carol. Remember they talked about it. So, right again, note how order is not guaranteed in the map, right? So that means, so is it deterministic? If I compile many times, it's going to change. I like to break things, right? Eve first, it's very interesting. Eve was actually added last, but it's printed out first. So order is different. This time Alice, Eve, Carol, Dave, so it's completely random. So, right, it turns out each build on run gives us different or a different order, right? So
to an extent, this feels like very unintuitive.
yes.
Because if they compile the map, I would imagine that there would still be some sort of order how they store.
Yes, because of course it's interesting why is it randomness how they add there's some sort of tree structure. Why is Alice like they must use some sort of random hashing. There's some random elements something where it puts because if you I don't know if you remember we talked about this how hashes are made. It's underneath there's an array, right, and you have an indexes, right. So you're basically generating index place where you put Alice, right. Out of Alice comes let's say 0, 1, 2, 3 or something, right. And for each of these, you get a value, right? The issue is how do you handle collisions, right? Maybe Alice and Bob hash to, that's why it's called hash maps. They hash to, let's say, value 7, right? How do you handle collisions? Where do you put the Alice and where do you put the Bob, right? If they have the same hash value, right? So maybe you remember there are different ways of handling collisions in hash maps. Maybe you go next empty place, or maybe you jump around. And I imagine to make it uniform, you don't want to cluster. You want your array, the underlying structure, to be evenly distributed for your hash values, right? For performance reasons. So you probably use some random element, or maybe you have another extra second hash, which sort of distributes these values more evenly. So that's, of course, it's a very technical issue. You have to read, of course, some technical documents. And I'm sure Go is pretty public about this. You can, of course, email Rob Pike or one of the developers, I'm sure, right? Yeah, so that's so. But of course, it seems a little bit, would be nice to, of course, sort them, get them in order, right? So what could we do, right? Let's get them ordered. So if we want to print key value pairs in order, we would, what I would do, well, yeah, keys first, right? So let's see, yeah. So sort, I think I need to import it, right? Yeah, I think I need to import it, right? And I think it's like this, right? Yeah, format and sort, right? Come on, sort. Yeah, we want sort as well. Come on. And we want, what is, I mean, sorry, we want this one, right? Yeah, sorry. Yeah. No, and we want sort. We want sort as well. Sort. I think it's mass sort or sort. Yeah, okay, it's actually just sort. All right. It's not used. Imported and not used compile. Okay. It's a warning, I hope, right? So what is main? I had something here. Oh, I declare something. Here, key value. Did I do something? What is the problem here? Let's take a look. Main. What did I do here? This is, they do double something? What does it say here? In this block, I think it's just confused. I didn't do any amazing as main. So for key value, right? So keys. So first, let's get keys, right? All right. Okay. Now let's sort the keys. This seems like really. I thought we could do something quicker, right? Yeah. Now now we can do it. Now we can do it, right? So notice again. Note how we note how we skipped the value here, but of course we don't really need. So range keys. I wonder if this is for key in range ages, right? Keys. Do we need this actually here?
I think yes, because it's
Yeah.
the index.
Yeah. Okay. What the heck is happening here? Did I miss it? Like a.
Was there over the main?
Yeah, it's saying it's declared somewhere in the bliss block. Other verse 7.6. Package main. No. What is it drinking?
Oh, because you have array slices.go where there is main.
Yeah, right. Because yeah, it's the same structure. Yeah. You're right. You're completely right. Yeah, but I think I can just ignore it. I think if I compile.
No, I doubt that.
Yeah. No.
Oh,
Yeah, I like I said, I like to break things. Yeah, it's not a good practice. You should have only one main in project structure, of course. Right? It goes without saying. But I'm lazy. Per package, yeah. But of course, it goes without saying. But I had to say it, saying that your project should only have one package main, right, and one main function, of course, right? Okay. Right, okay, but it works because, of course, I said it to. So yeah, so Alice, Carol, Dave, Eve, right? So kind of convoluted way of doing, but we learned some new things. We learned how to sort. So keys are sorted. So keys are sorted in place. All right, let's do a few more things. So we learned about error handling. Now let's go at structures overview. Let's do a little quick on structures, right? Meaning your structures, not my structures, well, our structures, right? We can make our, of course, a good programming language lets you do your own structures, right? So let's do some persons, things like that. We'll call this persons. I guess I'll call it persons. Go. I guess I'll call package persons. I guess I can call it like this, right? Let's explore making our own structures in Go. Yeah. Yeah. So a package. I don't know. Can I call persons? I guess so this won't complain about this. Okay, importer, right? I'll do import for now, right? Don't need anything else. Expect package main. Okay, I guess I'll just package main. I'll let again. I'm just sort of. I shouldn't be doing. I should have a separate place for this again. You know, the 3 projects in one map, right? So, so structures you have to define in Go, right? And let's do this. So, it has name and age, right? So, structure keyword, right? Type, structure, person structure, or I'll capitalize it, right? Yeah, I guess I have to person structure, name string, and age integer, right? Simple.
But I think it doesn't really matter if you capitalize it or not, if it's in the main package.
Ah, it will.
Be able
Okay, yeah, so that's fine. Okay, so let's take a look now. So we'll use it, right? I'll do a function, right, main. Let's get a person. Variable type A. Or,
There is typo in font.
oh, I can't type. How did I? So I'm so lazy. Yeah, dot. Of course, you use dot. Yeah. Okay, so let's do this. I'll do Alice. Alice person name Alice on age 25. Right, that's one approach, right? So named fields. But we can change the fields around. We can do it also another way if you have named fields, right? So, okay, you good to go? You'll be back. You shall be back. Okay, good. All right. So we could have a. Let's create a Bob. Poor Bob. Person Bob without age. Right. No age. We will add age later. Add age later. All right, let's print them.
And a comma after.
Yeah, comma. We need comma, right? So okay, why is comma good? Because it's a little tricky, of course. You can now you switch around. If you delete or comment things, you know, of course, it won't produce an error, right? So let's print them. Let's print these. So what's going to be these structures, right? Alice and Bob, right? So what is Bob's age going to be? I expect it should be 0, right? We'll see. Age.
I guess, yeah, if it's an integer.
Yeah, it's an integer type, right? So everything works again. Yeah, of course. That's yeah. Okay, of course. So let's do this. Go build structure. What do they call it? Persons. Persons. Oh, I don't have persons yet. I'll make it. I'll make persons. We'll build. Yeah. Bob is completely like a baby. Okay, let's add some age to him. Let's mutate. Let's add modify. So Bob's age, you know, simple stuff, right? So very nice. I think pretty easy to use, right? There's nothing. Oh, sorry. There's nothing complicated about this part here, right? Now Bob is 30 years old now, and so on. So we access, we can modify fields, right? Of course, we cannot add. It's not like Python. We cannot have custom fields, right? We could have actually. There's actually I think anonymous fields as well, but they use named fields, of course. Now, right? So we can. How do we pass structures to functions, right? So reminders that Go has pointers. Yes, it has pointers, just like C or C++. But the good news is there's no pointer arithmetic in Go, right? So no adding things to pointers, right? You know, because you know how pointer arithmetic is literally messy. You need to know the size of whatever data you're doing, right? Tricky. But we can do pointers with no problem whatsoever. All right. So, but what I want to show is structure methods. So that's kind of interesting. So let's make a greeting method, right? So this will be kind of interesting. So let's make a function. Let's create a method. Let's create a structure method for person called greet. Yeah. So this is a method. Go does not have pure classes and objects like we know, right? It's used something a little bit different, right? So in fact, I have some a student of mine who's doing a bachelor's on this. He's comparing like Java and Go, basically. I don't know how he's doing. He's kind of stuck in the middle of it right now. So, but basically, yeah. So Go is Albeit for simplicity, it's not, again, because of course the people who made Go, they come from classical imperative backgrounds. They're not the guys who made C++, they made C, right? So they have this tendency, they're not really big fans of OOP, I imagine, but they realize you need some way of doing it, right? Something like that. So let's do this structure, yes, of course. So, so function, right, greet. So automatically, hello, my name is, you killed my father, prepare to die, right? So, all right, so, yeah, you killed my father, prepare to die, right? No, no. So, you don't know that this reference, this is Princess Bride reference, of course. No. All right, so, let's greet, right? Now, so let's do, Alice will do a greeting. So let's make Alice do the greeting. Now, so notice what's interesting, right? So this part here, so this is, so note how the syntax is different from calling a function. Yeah, so this is kind of cool. So I said, okay, p person, right? All right, so this automatically, I can use this dot syntax. So that's kind of cool, right? You use this, I hope?
Yeah.
Yeah.
We
Yeah.
very often.
Yeah, okay, good. So let's see. Alice's greeting. You kill my father, prepare to die. So it works. Okay, right. Yeah, all right. So, yeah, so you can add more methods, of course, right? Let's add birthday method. Let's add a birthday method which will modify, right? So function, so we'll have a, notice what's happening here, right? Note the pointer receiver, right? So what does it mean? Why do we need a pointer, right? Because again, with pointers we have the memory. With pointers we can modify the value of the structure, right? Without pointers, we would not be able to modify the value of structure, yeah, which is useless, right? So that's why we need this. So this is a in-place modifier. So let's add a birthday, all right? Yeah. Show age. Yeah. So now we have our age. Let's have a birthday. Let's have Alice have birthday. Let's have Alice have birthday. Alice birthday. So in place mutation. Oh, yeah. Okay. You didn't drop anything.
No, it's fine.
Okay. All right. So Alice should be now 25. All right. Let's take a look. Yeah. So she had the birthday, right? Everything works. So a little bit careful here, but yeah, so this is a pointer, right? So pointer, of course, so we get a pointer, so this means we can modify the underlying structure elements, basically. Okay. Of course, you can do nested structures, you know, if you're doing only JSON, things like that, right? So, okay. Hopefully this makes sense now, a little bit, right? All right, so we're almost finished. Of course, you can go Toro Go is pretty nice. You can go through all of it, right? One more thing, of course, interfaces, right? We could talk about interfaces, I guess, a little bit, right? Yeah, let's go interfaces here. Now, interfaces, right? I hope here, right? Interfaces, right? Interfaces sort of let us do the things kind of like OOP things, basically, right? And I'll go example. I'll do some sort of shape or something like that. Yeah, do some shape. Shape go, right? And that will be our last thing today. So let's talk about interfaces in Go. Right. It's a way to define behavior, right? Again, you talked in Kotlin has interfaces, other languages, so we define what we expect, right? So a set of methods that need to be implemented, right? So the type will have to implement, So let's do this, right? So uh, let's do a create a shape interface, an interface called shape, which will have area and perimeter methods, right? Right. Let's start with package main, right? And import again, formatter, of course, for now, right? And now, of course, we do type. Type, shape, interface. It's an interface, area, float, perimeter, float. So this means, of course, so area should return float, and of course, similarly, should have float, of course. Now, right? And so now let's do a rectangular, right? We'll do a rectangle. Let's create a rectangle structure. We know how to make structures right now. Let's create a. Okay, let's create it. Let's create a rectangle structure. Type rectangle structure with float and height float. Okay, right. But notice we didn't say anything about the shape interface right here, but we will implement it, right? We will implement this, right? So now let's do a circle. Why not? Why not? Of course, it has different parameters, right? Type, circle, structure. It has what radius, right? And that's it basically, right? We'll need, of course, pi somewhere, hidden somewhere, right? Probably need to match that. So now area, right? And how about perimeter? Come on, yeah. We remember 2 plus r with, right? You know, simple stuff, right? How about circle? Circle. Right. And area, of course, for circle, you know, c pi. Well, that's kind of horrible, 3.14, right? You could probably get an import from somewhere else, right? You know, add to do list, right? And of course, perimeter is 2.2 times 3.14 times c radius. Okay, so we define our interface, right? So now the thing is, of course, what's interesting about this example is that we did not say anything that this rectangle is using this interface, right? So that's kind of interesting about this part here. I would have expected classically, like in most languages, you say that you're using it, right?
I think that is a big drawback for Go. It
Yeah.
makes it much less readable.
Yeah.
Especially at work when I investigate
Yeah.
projects. Well, it's hard to understand whenever they use some sort of
Yeah. Yeah. So let's make a rectangle, right? And let's make a circle, right? Radius 3, right? Or let's say 10, right? Let's do 10. Right, so on print article, so it works, right? So the question, of course, is, I mean, we could have technically, right? We could have skipped. I mean, what would have happened? Basically, now the thing is, what's interesting is, why do I need this shape in general, right? Why wouldn't it work with if I skip the interface part? You see, that's my question now. Is if you skip the interface, seems like it would still work, right? Except, of course, maybe there might be an overlap naming. Let's try. Okay, let's see if it works. Let's see if this works, and then we can finish today. So let's build it. Go build. Oh no, I need to go to CD interfaces, right? And go build shape, right? And let's run the shape, right? Yeah, okay, it works. Nice little, of course, we get our float, right? Our floating error, nice little 0.004. Probably in the, let's do a let's get a round, right? Function, right? Maybe round we need some precision or things like that, of course, right? So it works, but what happens if what kind of error will I get if I get rid of this, right? I wonder. If I just say, okay, I don't know anything about this. I'm doing my own thing, right? So will anything change? It's not yelling at me, right? So that's my interesting question. Is this actually going to compile, right? Yeah, it works. So the question is, where does the actual, you would sort of like the contract, right? There's no contract between these things, right? Lots of kind of things. Let's go quickly. Let's double check this. Let me go to interfaces. Interface. Oh yeah, so this here, okay. So we have our interface, right? Structure. right? We know that's right. Method, we know about methods, we just learn about the interfaces. Interfaces, methods continued, pointer receivers, functions, right, and interfaces. Set of method signatures, right? It's just a bunch of signatures, right? Apps, right? So is there anywhere where you, oh, implements, aha. So, well, let's see, where A is upser interface, okay, A equals F.
That's interesting.
Okay, let's take a look at this, right? All right, it's line 22, right? Okay, A equals F. Okay, so this is what's missing, all right? Otherwise, I skipped the interface and nothing happened because, of course, I did it everything. I just made methods. I mean, they same name, but for rectangle and for circle, right? We want to do this. This is where actually the point comes from the interfaces, right? So, if you implement A equals F, A equals at F, right? This is also that error, right? So, very interesting, right? So this means, of course, you have to implement, right? So this means it forces the floating, whatever. Ah, right, you have to implement absolute, right? You have to implement this here, actually. Interesting, very my float, right? Let's see. Structure, right? Vertex, right? So you have to implement this here, right? So function, right? So structure A equals F. So let's see, upser interface. That's an interface, right? So A equals F, and that forces it, right? So very kind of weird, right? F. Well, we'll see. We'll see. Let's look at more example. Implicitly, right? Yeah, so yeah, there's no, you see, this is really hard. This I think is, I personally don't like this actually, right? Because implicit, it can be very, it's implicit implementation. There's no explicit declaration of intent. Yeah. Right, so that's kind of interesting, right? So basically, I don't have to, I don't necessarily need this really. So okay, so technically, technically, I could skip having an interface and it would still compile and work, right? So
I think the point for the interfaces is to use it as in the first example,
yeah,
where you specifically implement them. Because
yeah,
I imagine if you have to, I do assume that you could implement many interfaces.
yes, of course you do.
So if that's the case,
Yeah.
then I guess that would be much easier to just list
Yeah.
in a couple of
So-
statements instead of writing implement.
Yes. I didn't want to do, okay. So, but what's interesting, so in a way of avoiding object-oriented programming, they create their own. Of course, like I said, there's no free lunch basically, right? You gain some clarity, right? So again, you can live without interface as well. So yeah, do explore how interface the reasoning, the why behind interfacing go on, why they are useful, right? So of course it's called again tip contract programming by contract. Yep. Okay, that's the idea. Of course, that's the idea. Again, but again, so it's very practical language. Again, using for server type applications, usually. That's a major thing. All right. So next week is still open up in the air on Monday, right? So whether we do Rust, right, which I think most people don't want to do, right? It's
Well, we could do some React. Or
yeah, something like that, possibly. Yes.
that would be cool.
Yeah. Okay. All right. So I'll see you guys on. Well, some of you I'll see you today. Some of you on some of you I'll see you on Monday. Have a great weekend. And I'll commit these. Let me commit this.